Okay, everybody, it's 10 o'clock. We like to give everybody a chance to join a little early. So thanks for joining, everybody. Again, if you're joining us on YouTube, please check out the links in our description or hit the subscribe button. We have a lot of content available, and you can join us here on Zoom to get your questions answered live. Today we have Javier Chavez joining us for part 4 of our 2D to 3D transition guide. Thanks for joining us, Jav.
Yep.
On the next slide here, I also wanted to share some of our upcoming events. Autodesk University is next week. It's taking place in San Diego, California. If you're attending it in person, I wanted to drop this link. You can schedule time to meet with us. Our leadership team is going to be at AU at the ANSYS booth. And Tiffany Hayden, one of our application engineers, is also leading a session. It got completely full, so they're hosting a repeat of the session. And she's also hosting a community meetup. So if you're going to be there in person, it's a great opportunity to not only learn from Autodesk, but to join us and meet up with us. Check out the link that I dropped here.
And by the way, do you know what the subject is?
Yes, it's called Vault Code Keeper's Path to Success. About, oh, do you already know?
No, I didn't actually, so I wanted to hear from you.
It's about storing your iLogic rules in vaults. I think I got it right. And we will also post a repeat of the session on our LinkedIn. So if you're not attending in person, you can check out the repeat of the session by following us on LinkedIn if you're not already. So yeah, you'll have a chance to still watch it even if you're not attending in person. And then finally, these are all of our upcoming KVA sessions for the rest of the month. Next week, we have Snigdha joining us to talk about ANSYS Discovery. This was a topic that one of you suggested on a KVA. So if you have any other topic suggestions or any topics that you would like to see covered, please fill out the survey at the end of the session or let us know in the chat. We're happy to listen to what you guys want to learn. Thanks for joining, everybody, and I will let Hav take it away.
Yep, and I'll just go ahead and kick things off with just a quick introduction. I've done quite a few of these. I haven't done a lot lately, but I did do one maybe 3 or 4 weeks ago. So some of you guys may know me just from delivering training or consulting projects. But you can see my background here. I've been here a while at KETIV, but a number of years just doing 3D design work and consulting, and namely in the manufacturing environment, right? For RV vehicles or motorhomes, travel trailers. I've spent a bit of time designing those, and you'll hear me talk about those quite a bit. And you can also see some of my expertise there. I'm certified with 2D and 3D and Inventor and AutoCAD, and of course with data management, which I think is a huge part of all this and often overlooked. So with that said, I think we'll touch on almost all of this, right? The 2D, the 3D, and the data management part of this in this session, and it'll apply. And if you have tuned into a lot of these KVAs, you know that this is part of a four-part series, and this is the one we're focusing on, right? We've already covered some of the topics above. Today, we're going to talk about the last step in sort of leveraging your 3D data, and they talk about magic there. I didn't put or create that portion of the slide, but it is amazing what you can do once you have 3D data in terms of automation and streamlining processes, right? So with that said, I'll just kind of review a little bit of what we've covered, right? In the first part of it, it was all preparation, high level overview. In another component of it, the second video, I think we talked about, how are you going to go planning about creating your content. In the third one that I delivered, I introduced you guys to some workflows on leveraging 2D data, as well as maybe bringing in static 3D data from step files from other sources and making sure that they're usable. And we also talked about, well, if you do have to start from scratch, what are some resources in order to start from scratch and create models and 3D data from scratch. So this last session, we want to make sure that we connect the dots and start to really leverage this, because honestly, the first 3 components of this are a huge investment in time to get up and running. and you really want to see a return on that. And you can see a return on that, just by some of the information you can glean from a 3D model. But I think you can glean a lot more or get a lot more from this last component where we automate and integrate into other systems. So you could see the agenda here. We're going to start off talking about design automation. I want to bring up an example, and we're not going to go from beginning to end in terms of creating or programming any iLogic, et cetera. But I am going to give you some really good resources and give you a live demonstration on what that looks like. And of course, again, with those resources, you'll see how you can get started. And we've got tons of resources on that. We've done quite a few webinars on that. And so you'll want to take a look at some of the pre-recorded videos that we have available on YouTube. And of course, if you want to connect with us and get more personal help, of course, that's always an option. But the other part of this is how 3D integrates, I think, better with data management. You can certainly work with data management in a 2D environment, but you can get so much more information and you could do a bit more with that 3D data than you can the 2D. Okay, so that's one of the reasons we go to it, is so that we can manage our data better. And so with that said, let's get into our design automation example. So just to be clear, I am referring to a previous data set that we published out there in a automation webinar that we put on. And so we're going to make available some links, some information regarding this data set so that you can leverage it, take a look at it, and get a bit more detail on this. So this is what you're going to see. And before we get into this design automation example, let's take a look at just some of the information in it, right? So in this case, we're doing an assembly only, right? And we want to create a new assembly. And the typical workflow that we're trying to automate is going through the process of having sort of a templatized tank here, right? There's a number of components present in this configuration, but we also want to configure it in the process and borrow things that are standard, that are static, that don't change, maybe in a library folder, and then also, copy components that are going to get changed, modified, lengthened. The diameters are going to change, or maybe they're simply going to be turned off. We want to copy those. And when we do that in an assembly, we want to update the reference so that we have one unique assembly with certain things that are standardized, that are borrowed and used over and over again, and other things that are changed, right? That are swapped out. So it does cover these concepts that you see here. Passing information back and forth between the files through iLogic, as well as through Excel spreadsheets, and building code and subassemblies. That's what this data set covers. Again, we are not going to be able to go through every component of this, but we have some pre-recorded information that you guys can use, and it's got a ton of detail. So with that said, let's go ahead and take a peek at what this assembly is composed of. And we've got a tank body, skid assembly. There's a number of components there. Each one of these has some unique variables or rules in regards to them, right? And again, we go into a bit more detail in some of the videos that we'll distribute out to you. But the tank body has two main components, like the ends or the heads, if you will, the dish heads, and the individual shell pieces that get copied along the length. So there are individual shell pieces that get copied and welded together here. So there's a number of pieces there. And of course, we want to control the diameter of that. So we want to do this in 6-inch increments, and we want to also control the lengths in 6-inch increments all the way from 36 to 600. So what we've done here is we've captured the rules, right? The logic. So we're not just copying things like I, maybe showed in the previous slide a moment ago. We're also adding logic to this. These are some of the rules just for the tank body. And if we move on to the skid assembly, you can see, again, it's made up of a couple components, and it's, completely based on the tank dimensions. So the diameter and the overall length determine what this skid assembly is going to look like. If we move on, there is a optional gun line assembly. You can see it kind of highlighted here. It's kind of a manifold where you might inject other chemicals into the tank itself. And there's some dependencies there as well. So as an example, this is only available for tanks that are 60 inches in diameter or above, right? There's only two options, and the number of spray nozzles is, coincides with the number of shell plates. So if there's 1, 2, 3, 4 shell plates, you're going to get that many nozzles. Okay, so a lot of rules here, and we want to, just highlight that, throughout the data set, you can get I guess a copy of this PowerPoint to see, what's the point or what's the limitations on some of these components, to see what the idea was behind the automation. And so in just a moment here, I'll go ahead and open it up, but you can see it, we kind of identified all the little nuances of the components that are in here. So again, I'm not going to, read everything here. I'm going to basically start opening this up, and we'll go ahead and, show you what this looks like. So with that said, let's go ahead and take a look at the actual assembly. Okay, so this is a finished version of this. And before, I actually, open this up and launch it, let's take a look at what comes in the download or the kit. Right, so you can download this kit. It comes with the documentation. There's code there that you can copy and paste for a number of things. It comes with a number of resources here for identifying, what the point is of, I guess, of this data set. And they're super good resources, right? There's a lot of documentation there that you can leverage. You'll also see, a number of files here and inventor files to start off with, where you could start, working on this and using it right away, and even modifying it. So some of this information comes from Excel. So if I open this up, some of the information for these components comes from Excel, and you can see if the length is 48, then other parameters are going to change accordingly, right? We could do this inside of Inventor, or we can bring it in from Excel, wherever it makes sense to bring this from. And again, there's different tabs that control different things. So again, if the tank diameter is this, then the dish depth is going to be this, and we can extract that kind of information. So that is all there present. And for right now, I think I'll just come back to the actual example and just kind of show you how this works. So this is a finished example. Let's go and create a new one. And a good use case for this, right, is if you create tanks over and over again, we want to sort of streamline the process and standardize it as well, right? I've got a template here, and the data set or the exercise that we're going to send you to doesn't necessarily put it here in the template folder for you to start off with, but it's very similar, and it's a good way to standardize this and distribute it to everybody so that they can start off with a standardized assembly. So if I create a brand new tank, as soon as I create it, right, I get prompted with information. So one of the goals here is to basically organize the files that you're going to create as a result of this into a set of logical folders. So if I were to look at my previous example, just put this away for a second, you can see here, this assembly name is KETIV, and it's got a serialized number after this. And so one of the results that we get after using this is basically a set of folders here. So if I look in where this got created, it created the folder where the files are going to reside. It also named some of the components accordingly. So there's the assembly. It names it according to what's in that dialog box. Some of these components are unique to that assembly. So you can see it adds a suffix here with that same serialized number. And then other components are shared. So if I go back and I look at the folder structure, there's a library folder. These are shared, they're read-only, or they should be anyways, and they're standardized. So you either use these valves, right, or you don't, right? And you're not allowed to change them, right? You just choose between some of these valves. So to go back to my model, right, And specifically the assembly I just started creating. There's nothing in the background here. I'm going to put a project ID, and in this case, I'm going to put KTV here, and maybe a serialized number like 1, 2, 3, 4, 5. Okay, and then I'm prompted with some of the information that we just talked about, right? So the most important part of this is this here, and obviously this is an iLogic dialog box that you don't normally see in Inventor, all right? That's specific to configuring and designing tanks. And this is where our slider resides here in order to specify in 6-inch increments what the tank outside diameter is versus the length here. And again, this is also, I think, in 6-inch increments. Okay, and we could simply slide that. Now, I'm not going to click create just yet. I'm going to go ahead and make some more choices. So the inlet, how large is that going to be, right? This is pulling from a drop-down list inside of that spreadsheet, right? And then we've got choices on whether those are going to be, those are going to have, welded on fittings or lapped fittings, etc. We've got some choices to go through there. So with the drain, we can include them, exclude them. Do we want a valve at the end of that, or do we want it to be capped? We've got these options. And then when I get to, I'm going to leave this one open. When I get to some of these other options, you can see here, they're turned off by default. So if I put a check next to this is where I can add my manway, right? And decide, from these 3 options, right? I'm limiting and standardizing how I can do this by just providing 3 options. So I'm going to go ahead and maybe put this in the middle option, put in hatches as well. So again, optional. And then we can space them or put them, offset them from the ends here a certain distance. So one's going to be offset 8 inches, one's going to be offset 10 inches. Okay. And if I take a look at that gun line information, that's that sort of manifold that we saw earlier, right? It's available now, but it's not available if the diameter is less than a certain number. So I think if I bring this down, you can see here, if I go below 60, that's no longer available, and I cannot put a check next to that. So the whole idea of this, right, is to put in place rules that meet, your the logic of, how you might build a tank, and you're going to want to capture that, document that, and put that, into code. So this goes through an exercise of doing that, and you'll see here, I'm going to go ahead and length or change the diameter here so that I can maybe add a gun line, and you can see the options there. I'll leave it out for this one. And then the last thing is I'll do is put in a sump, right? So more geometry that goes on the inside of this. This is for the assembly only, but you could easily, add code or automation to also create the drawing. So that's all we're tackling here in this example. And I can go ahead and create this tank. And you'll watch it basically start to generate all the geometry, create new files, replace components here as we go along. And, in just a moment, I'll have a brand new assembly. So if you can imagine having to create a number of these, fairly often, and constrain them and put them together, right? This is saving us an immense amount of time, right? So we now have our assembly here. There are, internal components being created and assembled, and I've got this new version of a tank. If I save it, right, you can see the naming convention and the folder organization here, and I could, obviously go back to Windows here and show you that as well. All right, so it's also organizing the files, and you can see it created a new folder for that project with that serial number or serialized folder number, and all the components are named accordingly with that prefix or suffix there. So great example as to how this can streamline the process of designing or creating a tank. I'll come back to my PowerPoint here in just a sec, right? And we got to see a lot of this. If you want to see a bit more detail and get more step-by-step type instructions on this, this is what I'd recommend. I'd recommend going to our website and signing up for the DIY automation kit. There is a video that goes along with it, and so we'll share those links. In fact, I'll go ahead and click on the link here just so that you can see it here. So you will have to enter in some information, no problem, but then you'll be able to download that kit. And then on the same page, there's a link to watch the video that's associated with that. So when you click on that, it'll take you to a YouTube video that Nathan Eliason put together here and presented. And it goes through a bit more detail on the idea behind this particular tank in terms of automating it, the code that goes behind it, and what the overall workflow is for this particular design, including things that we've done in the past or talked about in the past. How are you going to put origins in your 3D components in order to make them available for automation to quickly place and put in the right location. So he goes through quite a bit of that, and a number of methods to do the same thing in just different ways and some advantages. So I would definitely take a minute to take a look at that, and also download that kit where you can kind of play around with that automation. Not to mention, if you search our channel, you'll find a ton of information on either iLogic or automation. And you can see here, if you do go to our channel, we have a link there, but you want to search right here within the channel, not necessarily at the top. This will search and filter just through the channel in order to just see the videos, past videos on iLogic. And there's tons of examples of different types of things you can do with that, because it's so broad and expansive. You definitely want to just take a minute to search maybe individual topics within iLogic to be able to get what you need. Okay, so with the data management component of this, right, it's super important just because we obviously one of the big benefits of having data management in place is revision control. And so if I come back to this folder, right, one of the things you're going to be concerned about if you have automation, right, is securing this data. Now, specifically, the data you're starting off with. So there's templates here, right? And this starts off with, maybe a skid assembly template, and it renames it and it lets you stretch it and change it, etc. Okay. But could you imagine, I mean, just somebody right-clicking and deleting this stuff and suddenly your automation doesn't work? Or somebody opening this geometry, editing it, right? Making changes to it, not realizing it's part of an automation, um, you know, uh, component, and suddenly that automation doesn't work. So there's a number of reasons you would want to do this for production, but in an automation environment, it's super important as well. So with that said, right, you definitely want to provide some control over who can edit and modify that data and even lock it down when it's ready to be used. So in addition, right, in terms of integration with your 3D, if you normally have to go through and publish information like PDF step files at the end of a project when you're releasing it to get it to the right people downstream, a lot of that can be automated through data management, and specifically Vault, right? So we can do that. We also have access to the bill of material information, right? And you have access to it through a couple ways. So I'll get into Vault here in just a moment. But as I'm bringing it up here, you can see I'm logged in, and one of the things I have here are some of the iLogic data templates, library files that should never be edited, right? Unless somebody's making some planned changes to the automation. So you could see the dish head here is locked down. You can see that lock next to this, it's released. So if anybody decides to change it, we have history of that just within iLogic, not to mention, for production. And then, of course, the files that got created that are unique for that design get their own folder, right? Their own unique name, and so on. So I purposely went to this design here. This is the design I had open just a little while ago. And with this particular design, I left it in a work in progress because I basically want to show you what some of the results are. When you release this, we can automate the process of releasing this data and creating PDFs. So if I want to go ahead and release it and call it done, you can see it's picking up the entire assembly. A lot of this is already released, but the drawing has yet to be released, right? So I'm going to change that drawing at the top here to released. And we can click OK, and that's going to trigger things to happen. So you'll see this change to released here, right? So it's now an officially released thing, and that's the right time to generate a PDF. For assemblies and parts, it might be the right time to generate a DXF or a step file. We can identify those so that not everything gets a DXF and not everything gets a step file. In this case, we've identified that only drawings get PDFs. So with that said, I'm going to go ahead and kind of just open up this job processor. And in the background, it's going through the process because we've triggered it, right, through a release process to do things. It's now creating the PDF. And once it's done, that's one less thing a designer or drafter has to go gather or do. It'll simply be there. So in a moment, it'll complete. We'll come back to it. But while it's doing that, let's also take a look at what else we could see, right? We cannot get a BOM very easily from 2D data. So if I go ahead and select this assembly, the one that got generated from our automation, right? Because it's 3D data, Vault is already recognizing in a CAD BOM tab, right, the components that are there, okay? So there's one of these, right? There's two of these. We get to see that through Vault, and we can leverage it right away. If we want to go ahead and do other things with it, we can. This is one way you could do this. This is through data standards that come with Vault, and it's just an add-on there. And once you add it on, it can do a number of things in terms of standardizing how you create data. But one of the things it adds is this CAD BOM data tab, right? So without having to go to items or use an item workflow, you can see that information. We can extract this information as well and send it to other places. But here's the other option we have with this. We can use items, and there's a whole list of reasons you might go to items to manage those. But I'm going to go ahead and assign the assembly to items so that we can see these as similar items to what you would see in an ERP system. Okay, so we're doing this at the assembly level, and in the next dialog box where it's sort of completing the assignment of this item, it knows that the assembly is assigned to this. It assigns the item according to a part number or a file name. There's a couple ways it could do that, and then all those things, right, that make this up show up here as a BOM. So this is another way we can manage the BOM, and we could do it directly from here. The big difference is we can add other things and sort of manipulate the BOM from here, add other items, things we don't model like glue, etc. So if I save this, we'll have some items there to work with at some point and be able to export to another system. These are readily available to send out to another environment like an ERP environment or manufacturing execution system where we want to work with that. And so if I look at this now in this item environment, this is a big giant list of part numbers, basically, right? And these part numbers may represent assemblies. They may represent a number of things here, right? In this case, if I look at the tank we just created a moment ago, right, it's the entire design. It shows the bill of materials. And if I wanted to take this bill of materials and export it out right now for use in an ERP system, I could do it right now. So this lends itself very easily to just creating a CSV file that can be ingested or brought into an ERP system, or manipulated a little bit further in an ERP system. But you can see we can go through this export process and create a CSV file or a TDL or an XML, depending on what format is acceptable, right? So I'm going to skip that. for just a moment because I don't have an ERP system to necessarily show you how that goes in, but it's already integrated. It's already showing you that information. And if I go ahead and minimize this and come back to um, our presentation here, right? The other part that really starts to become obvious, right, is how you can use or leverage that BOM data in other places. And you could do it manually the way I started to do it a moment ago. But the best way to do it is to have it automatically triggered by maybe the release process, similar to how the PDFs got generated or the step files get generated. The release process can trigger a process in the background to run and automate the export of that BOM to another system, namely ERP. The last thing we want to do is hand over a sheet of paper or a PDF to somebody who goes through the administrative process of entering new parts, new BOMs, or manipulating them just because they can, make mistakes. So I've experienced almost all of this, outside of KETIV in the RV industry, and this by far was one of the most productive things we did in that environment is automate our ERP export so that we no longer have to do this manually, right? And so we can support a number of things through our own connector, which is a data bridge, and we can connect to a number of things. But in this case, we have templates available to that are kind of standardized. Everybody wants to, work with part and BOM release or go get item masters from ERP and send it back into Vault. And again, these are triggered by the workflows. So we can sort of automate this so that, again, anytime you release something, within 5-10 minutes, you can look in an ERP system and that bill of material that matches will be there. Okay. So with that said, I'm going to come back here and just close up here in just a moment and just summarize a little bit of what we saw, right? We saw a bit of efficiency through automation. I mean, I can create 10 tanks very quickly, right, via that automation. And they're not 100% done, but they've got, I'd say, 80 to 90% of the work already complete. And that's huge in terms of efficiency, right? In order to maybe leverage that, some of the information you saw, you're going to want to go to this website here. We can make that available to you guys and download the kit. There is a video that goes along with it. There are instructions that go along with it. Nathan did a good job of packaging that up so that you can download it and start working with it right away. And of course, you could certainly contact us for any large scale or small scale automation services. We do this fairly often for specific industries. We have a ton of experience with the tank industry and specifically more holding water tanks. Or commodity tanks, et cetera. And there's a few other industries that we've been doing this more recently with as well. Okay. And last but not least, right, you want to utilize, data management so that you can get as much as possible from that data that you've, worked so hard to create. So that 3D data contains a lot of valuable information in terms of part numbers and quantities. And, if you go even further, there's a lot of physical information there that you could leverage even FEA as well. So those are some of the advantages of just going from 2D to 3D. So with that said, I'm going to go ahead and stop here for just a moment and maybe open it up for Q&A. And I'm curious, Christina, if there are questions in the queue now.
I don't see any questions, but Infinity CAD was joining us on YouTube and said, "Thank you very much. This was very informative." So thanks for joining Infinity CAD.
Awesome. Okay, and if you haven't already, taken a look, I think we put a link to the kit in the chat.
Yes, I did put that link in.
Awesome.
And I'll be sure to link it on the YouTube playback as well.
Got it. Okay, I see some thumbs up there. but it doesn't look like we have any other questions. So with that said, does it make, I think it probably makes sense to conclude. And we'll go ahead and just thank you guys for attending today. We appreciate it. And of course, if you guys have any questions for us, you can see some of the information there. You're more than welcome to contact us and ask.
Thanks for joining, everybody, and thank you, Jav, for hosting the session. We will
Yep.
see you guys all next week, or we will see you at Autodesk University. Have a great day, everybody.
All right, thanks everybody. Bye.